those steps or build out these experiences themselves, because it's incredibly painful. And especially when you're dealing with payments like this, it's an easy abstraction layer that you can integrate in. So we'll take a look at the architecture of this toolkit and how it works from beginning all the way to the end, from the payments to the verification step that you saw there, verifying whether the data already exists. And then we'll take a look through the practical implementation. Now, taking a step away from the architecture and moving more towards actually committing payments or enhancing the toolkit with your existing inventory or identity stores. And then we'll start driving into these nice little webhooks and how to extend the toolkit with those type of identity and inventory systems that already exist.
Before you go into the architecture implementation, from a functional point of view, in a typical e-commerce flow, right, a user is expecting on giving a credit card some type of confirmation, how much it is charged and not charged.
Right.
Do you have those type of flows here, or you do not have those?
So the type of flow that's built in directly into the digital goods flow is through the PayPal account. So your PayPal account can be bound with your purchasing information like that, so that you can just sign in through your PayPal account without any credit card information and just go completely through the flow.
So you don't have to send them an order confirmation or any of those?
No, what you see is what you get. That's all the steps that you have to take within there. You sign in through your PayPal account, you get a purchasing information saying this is how much you're going to spend, and then you go through. That's it. And then it'll attach, let's say, to your bank account and then pull the money directly from there, coming into the client.
And the second question is, typically credit card verification or whatever takes some non-real time. I suppose you're going to talk in detail how you're going to manage that.
Yeah, we'll take a look at really how to build out this toolkit side of things, and the payment flow will be a standard express checkout through a digital goods flow, and we'll take a look at how that works and how that works from piece to piece. Okay, so let's start things off by taking a look at the architecture, so that you have an understanding of how the program flow works from beginning to end. All you really saw there was a payment flow allowing you to check in, but there's a lot of pieces there. There's a lot of players in our little game of payment architecture that we're going to have to start working with. First and foremost, within the toolkit, we have both client and server-side interactions. What you saw there was the Express Checkout digital goods flow, which is bound through a JavaScript include. Now, JavaScript include also has payment functionality on the server side for doing all the billing and the verifying and getting all the token information that you need to make these purchases actually go through. We have the server-side implementation just because of the security reasons. Then you have PayPal Digital Goods, which is going to be our payment method. We're going to utilize that to push through these digital goods payments. Push through the payments, whatever we have within our PayPal accounts. Then we're going to be utilizing HTML5 local storage on top of this existing flow, to basically bind to success action. So you make a payment, and we're going to use HTML5 local storage to actually speed up the integration and actual verification steps of verifying that those purchases were made. Because obviously you're going to want to load up some things. Let's say you have a game where a person can purchase something for a week that works for a week. We can store that in local storage as well as a couple of backup utilities, and actually verify those when the game reloads. And finally, a little bit of jQuery in there to do a lot of the cross-browser functionality, a lot of the client to server-side interaction. So that's just something that's built into the toolkit. It's not something that you're going to have to work with. We just chose to utilize that as our JavaScript library. So if we jump through and look through exactly the components that are available. First and foremost, the vast majority of the interaction that you're going to utilize on this flow is through the JavaScript side of things. This is where you're going to build out your billing handlers, your verification handlers, everything that you need to get started. And the toolkit already comes pre-configured with all that information, so you can just utilize everything that we have there to build out your existing flow. Then on the server side of things, we have a couple of different language integrations that you can use. PHP, Python, ColdFusion, and Java. A lot of these integrations are, well, actually all of these integrations are identical in nature, so they really have the exact same functionality, just a different server-side angle. So that depending on which server-side language you're working with, you can implement that side and just cut out all the rest. If you want to reduce the file structure, reduce the load of the file structure, then you can just wipe those directly out of the project when you load it into your existing architecture. Okay. Now let's take a little bit of a look at how digital goods actually work. How the flow through PayPal will work from beginning to end, what you saw up there. Digital goods will first start by fetching a token which will allow you to display that light box and start the committing of the payment. So what you're going to do, what the toolkit does behind the scenes is make a request to get this tokenized value. Essentially, I like to think of it as a unverified request token, which will essentially say bind to your application, push you through the Lightbox flow, and allow you to commit your payment through. Once you have that request token and the Lightbox gets displayed, that's when you can start entering in all your details. So that Lightbox can then be generated directly from the digital goods JavaScript include. Yes?
So I'm a little confused. Who generates this token?
So the token is generated when the backend request is made by PayPal server, so we send that directly back to the flow. This is all bound into the existing toolkit, so it's completely abstracted to the client.
Okay, so the server, so I'm contacting your server goes up to PayPal, gets the token, and returns that to the user or redirects them or something?
So the way that it works is user goes to, let's say, your game on your server. The server, utilizing the toolkit, will make a request to PayPal service to get the token. The token will be sent back to that client, with that server that you're implementing with, and then that token is used on the client side through the toolkit to generate the Lightbox.
Okay. Is this an OAuth flow, or is it something different?
This is a custom integration of Express Checkout.
ExpressJ?
Express Checkout. It's a payment flow through PayPal. All right. So once you have that Lightbox, that's when you're going to go through that committal of payment, where the user is going to say, yes, this is my account. I log into my account. Yes, this is what I'm going to be purchasing. So then you're going to actually commit the payment. This is the client making another request to PayPal servers in order to commit the payment after the user has verified, yes, please take the money, and I want this good. Yes?
Are you doing here the token as an anonymous user or as a user with appropriate credentials?
So this will be a user with proper credentials being passed through. I'll show you exactly how to set up how that application credentials come through. Probably, I think it's at the end of the architecture step or at the beginning of the next step. I'll definitely go through that.
So that means here, before fetching the token, you're asking the user for credentials and then fetching the token?
Well, the credentials, so the fetching of the token side is all done behind the scenes. The user's not even exposed to that.
But that means the user is already priorly logged in?
No, the user logs in through the Lightbox flow. So the token's really just to generate the Lightbox itself. It's really just to saying, this is my application is valid, here's, I can generate the Lightbox and push the user through the flow, and it's basically a way of binding the application to the user's payment. All right, now once you commit the payment, then you, of course, verify it. So when you saw, for those of you who are in the room, when you went through the JS Wars demo, you saw right off the bat we were trying to verify. We were trying to verify whether the user actually had made that payment already and whether we can just unlock whatever good we had given to them. And it works pretty well when you have something that's continuous, like something that lasts for several days or weeks, or something like music. Just something that's longer lasting than an immediate use. In the case of the JS Wars demo, that was really just 5 missiles or some mega shields that get wiped out like that, probably in the exact game. So the verification step is actually taken right at the beginning. You can verify the purchases, or you can do it near the end if you'd like to verify the purchases that have gone through. Okay, now, to identify a user, there's really a couple of ways that we can do this within the toolkit. Because I know there's been a few questions about the identity of the user and really where we're pulling the details from. First and foremost, and we'll go through this exact flow on how this is actually bound back to an existing inventory store. But the client themselves, the person who, or the company that integrates the toolkit, can bind that toolkit and really the PayPal unique identifier for the user back to their existing client store. So this way, you have your existing users, and instead of having to rebuild your architecture, you just have this abstraction layer to bind directly to that PayPal unique identifier. So that way, you can identify a person on the PayPal side and automatically push through the verification of the goods right away. So that's first. And then, obviously, the second one would be an unknown user comes to your site, your service, your application, and they enter in their PayPal credentials, but they're not known to you. Just like you saw in the JS Wars example, the user wasn't known to me because I had no local storage aspects, I had no inventory store, no identity store. Nothing was built out to identify that user, so I had to go through PayPal and identify myself there. Now, once you have your identity in place, where now we understand where identity is coming from, now we can start fetching that token for the Lightbox and actually displaying that. What happens is, just like we discussed, the application itself will make a request to PayPal servers saying, I would like to display a Lightbox to actually push through this type of payment, this inventory for this quantity. So the request is made to PayPal servers, and then if it's a valid application credentials, that token will be produced back. The client can then utilize that token to initialize the digital goods Lightbox experience, where you can log in and you can actually make your payments. Once that full experience is done, that's everything that we need to display Lightbox itself. So Lightbox is displayed to the user, allowing them to enter in their credentials. Now, we left off right at that Lightbox experience. So the user is being displayed a login step for entering in their credentials and accepting the payment, right? Just like we saw before. The inventory information for what we're actually going to load up, much like the identity information, can come from a couple of sources. So this is what is going to be like your Mega Shields or your Super Missiles or whatever you want to sell in a digital goods aspect. It's first and foremost can come from the application experience itself. What you saw right in that JS Wars demo, for those of you who are here, was the application actually binding to a specific inventory item. So I was basically saying, I would like to send through so many missiles for so many dollars. So that was bound directly, statically integrated within my billing flow. That's one thing that you can do if you have maybe just a couple of digital goods, goods that you want someone to purchase. It's a very light touch approach, but unfortunately it's not scalable. So that's why we have an abstraction layer in place to bind to your existing inventory store. So utilizing these webhooks, which we'll cover at the end, you can bind your existing inventory store to the existing HTML5 toolkit and push those inventory items based on some key press or some action that the user takes. So that's a way of really building a scalable architecture within this flow. Okay, so the Lightbox is displayed. Yes?
Quick question. When you bind the flow, are you also sending, or can you also send a description with it, or are you basically just sending the kind of hidden amount?
Oh, it's going to be actually quite a number of things that you can send through: a description, title, payment information like the currency, the amount, all of that information.
Some are mandatory and some are optional.
Right. Yeah, and that flow is completely taken care of within the digital goods experience and the HTML5 toolkit. But there's a couple of things that you can override based on your inventory. Yes.
I might be getting something confused. When you're looking at your inventory store, does it also keep track of history so that someone can say, quick order last thing I purchased?
So the way that the inventory store works is it can be any type of inventory store that you already have existing. We don't predefine what that is. We just define within the toolkit how your existing inventory store works with the toolkit, and in that essence works with digital goods.
Okay. I wasn't sure if it was on my side or on PayPal's side.
It'll be
on my side.
Yeah, it'll be completely on your side. We don't care what the inventory store looks like. We just need to have data transmitted in a certain way in order to build that abstraction layer. Okay, so when the user actually goes through and says, yes, please take my money for this digital good element, they will approve the transaction, and then PayPal will return that transaction data, saying that the user has accepted that you can take the money. So then the client itself can make a request back to PayPal servers to actually commit the payment through. It's actually a commit payment step of the express checkout flow. So that is how you actually make the money transfer from the client to the, from the user to the client. That is the step that you saw when the light box was closed down and was actually passing the payment through. Okay, now comes the aspect of storing data. And once the payment is actually made, since it's a digital goods flow, since we're really building out real-time applications or applications that might need this type of real-time flow, we want an easy way of storing the data. So first, what we can do is we can store the identity information. So the unique identifier for the user that they go through, we can bind that to our existing identity store. So using that webhook architecture, which we'll cover all the bases on how you do that, you can bind that identifier directly to your existing identity store. That way, it will completely abstract out user-to-user interaction. Then, we also store transaction data. We do this in two ways. So within the toolkit, first thing that's going to happen when you actually commit the payment through is we're going to store the transaction details within HTML5 local storage. Now this is just going to be a quick lookup for the payment details, completely abstracted out so there's no security issues and everything's secured there. But for those of you who have played with HTML5 local storage before, you can wipe out the records, you can modify the records, you can switch browsers, you can switch computers, and then the record's gone. The last thing you want to do is have someone purchase a good and only being able to use it in that browser in that section as long as they have local storage enabled. It's a horrible, horrible experience, so that's why we have the secondary aspect, which is the inventory store binding, or the payment store binding. So what we do is we'll have those webhook architecture to take those payment elements that are sent back and push those directly to your existing payment stores. So you'll have your payment history set up, much like you asked, Ted. The payment history is going to display everything that you've purchased. You can take that payment architecture that comes back from the committal of payment and push that directly into your payments. So using this webhook architecture. So that's another way of tracking it on your side as well.
So what happens if, let's say, like client didn't purchase certain items, but he went to local storage and started inserting the records? Would you actually verify that?
Yep, we run a verification step so that when you saw the demo and going through the verification steps, we'll actually make a request back to PayPal servers to verify that the purchase is valid. Because the last thing you want is just someone hacking in a couple of records and getting whatever they want. So we do verify everything within the toolkit. Okay, that leads me to the verification step. So the verification step is dead easy. We have a client that the client itself will make a verification step based on an item identifier. So we have an item identifier that the user has purchased, and we'll push that to PayPal server saying, did this user indeed purchase this item and is it valid? And PayPal will return the description information on whether it's valid and whether the user actually purchased it. That's the verification step that usually is made right at the beginning of the flow. We can make it automatically at any time you want, but traditionally you're going to want to load it on game or application load to preload all of the digital goods that the user has actually purchased. Okay. Now, when we have the storage and mechanisms all in place and we do all the verification steps, the inventory data is going to have to come from somewhere. And like I talked about before, it's going to come from a couple of places. First, it's going to come from local storage, where we store things locally in the browser and we can just automatically load those in and then start verifying the item identifiers for the user. It's a quick, easy lookup because we have bound item identifiers for the particular user that's coming in for the browser session. Now, as an additional check on top of that, we also do the client inventory system checks. So if you do set up this kind of webhook architecture inside the HTML5 toolkit, not completely necessary, it can work completely without it, that is with the demo, you saw that. There was no inventory or an entity system set up to hook in. But you can have this additional verification step. So if the user switches browsers, it's good to build kind of this more concrete flow, this more reusable flow, and scalable using a client inventory system.
Do I understand is that basically if I buy a game using, say, Firefox, and then later I switch to Safari, the code would first look in local storage, wouldn't find anything in local storage, because I just switched to Safari, and then the client inventory system would be something online.
It would be something on your existing system. So you would basically store the purchases for the user in your existing database or what have you, and then push out those records. So that's where the abstraction layer comes into play. It's just going to push it through the payment architecture. Okay. No, so now we know where our purchasing goods are actually coming from in the actual flow within the toolkit.
And if I understand it right, you don't even need local storage, right? Let's say if I use IE 6 or 7, it's just basically going to say, okay, the local storage does not exist, and I'm just going to get the data out of the server side and keep using it, right?
Absolutely. So one of the things that can be used to enhance that functionality for older browsers is doing cookie storage. But since it's such a small amount, it's very hard to store a massive amount of data. That's what, like 3-4K that you can store of data within a cookie. That includes the headers and all the keys. So it's very minimal compared to local storage. So, that's why we chose not to really integrate that. But it's a good extension point if you want to integrate that for all the processes. Okay. So that's the flow end-to-end. I know it's a ton of information. I know that I just bombarded you with these flows from payments and from like everything that's going on in this toolkit. And disseminating all that data down and understanding it is hard with a new system. So that's why I want to go through the actual implementation of the toolkit. Everything that you're going to be working with from a client-side perspective, that's different from the architecture. So the architecture is a complete understanding of how everything works if you want to rebuild it, if you want to build it yourself. But if you want to just use the toolkit, that's where the implementation step comes in. So let's look at a little bit of code for that. First and foremost,
But just before going there is one flow that I still see, I don't know where it is going.
sure.
Once, in the very first case, when we are doing the purchase, right, and payment information has gone to PayPal, from there on, I'm just setting some server-side backend, some subscription entitlement to our system.
Yes. So, I'm sorry. Yeah. So the way it's working is once the user has verified the purchasing, what's going to happen is the client-side approach, all that light boxness, is going to make a server-side request to whatever language we have, and that is going to actually commit the payment through. The payment will be committed on behalf of the user to the client.
Okay. And what will be the SLA for that? How soon that verification can be done?
The verification can be done immediately.
Okay.
Yes.
So that means the subscription entitlement is almost near real time. That's what it is.
So this will be a single purchase that comes through, a single purchase as opposed to a subscription type of model.
Okay.
Okay. So the entire source code for this entire toolkit, I'm integrating it, is available on GitHub. It's open source under the Apache 2 license, so feel free to use it, abuse it, commit back something. If you have some server-side architecture that you want to build in, go for it. We'd love to have those examples back into it. Or if there's just something that you want us to work with, file an issue, and we'll take a look at it, and we'll try to fix up anything that might be of issue, or anything that you want added, and we'll definitely integrate those in. Also, if you're looking at the architecture on GitHub, feel free to take a look at some of the other branches. So under one of the branches is a JS Wars branch. Utilizing that, you can go ahead and just download the entire game code. It's an older version of the HTML5 toolkit bound with the JS Wars demo. So if you want to easily display how it's going to work, go ahead and download that, load it up. It has predefined credentials baked into it, so you can just start working with it. It's a sandbox credentials built in. Then later you can create your own accounts and override all that information. Okay, so within the toolkit, there's a whole bunch of files that you're going to be working with. The primary ones are displayed here, and I'll just cover them very quickly. They're really not as complex as the list makes it seem. Index.html is going to be your sample integration. This is going to show you how to include everything, how to create a billing and a verification handlers to really generate this entire flow. So you can bill based on that billing handler, you can verify based on the verification handler. So everything's baked right into there to get started easily. The entire client-side flow is put in client/pptransact.js. That's going to handle all the back-end requests to our server side, as well as doing a lot of the architecture. Also, I'm going to give you a link to these slides in case they said you don't have to take any extensive notes, so you can download all of this. Then on our server side, we have a lot of our file architecture for handling many of the use cases that we're going to encounter within this payment flow. We'll have our cancel, as well as our success elements, and when you actually, when the user will actually push through the payment or they'll cancel the payment, you can display these pages right off the bat. So in that Lightbox flow, you can display a cancellation message or a success message automatically by binding to these existing files. Then you'll have common, which will be your common functions, common credentials, things like that that's used throughout the entire program flow. The identity and inventory is going to be your webhooks for your existing inventory and identity infrastructure. And then of course pptransact.whatever extension will be the core program flow on the server side, just like pptransact.js is on the client side. Okay. So before I go any further, you saw a little bit of the PayPal sandbox and how to create credentials. The last thing that I want anyone to do is do any of this testing against their production level accounts, because it's not a good idea. So utilize the sandbox accounts because they're really nice for just creating predefined users, predefined merchants. So that's all available if we go to developer.paypal.com. If we log in, we'll see this home page. Now, to get my credentials for applications, I can go under API and payment card credentials and create my credentials right here with my password and username, predefined signature. So everything I'm going to need to do to push through payment flows. But the real one to keep in mind is this test accounts. Under test accounts, as soon as we load through, Wi-Fi, don't fail me now, we have a series of merchant and personal accounts. This is where you can actually set up these test emails. When you saw me log in through the JS Force demo, I logged in with this merchant email address with my, my predefined password, but we can create those just by clicking on pre-configured, and I like putting in pre-configured because I'm lazy and I like everything done for me. And then you can set up just a buyer account, seller account. So if we set up a buyer, we can say test, user, tester, some predefined password, what we want to bind to, credit cards, predefined account balance, if we want to set up 500.
So when you said the login email tester@yahoo.com, what does it mean?
That's going to be your login.
Oh, okay.
Yeah, your login test email.
But it doesn't allow duplicate, right? Like, is it unique per?
Yeah, so this will be your unique email address that's bound to the sandbox account, right? So when we create this account,
So how does it know that I'm logging into my sandbox account? Do I have to log in? Let's say. So how does it, like? Do I have to first log into my sandbox? I already have to have a session.
So when I went through the payment flow and actually logged in as a user, I logged in with this email address. So it's a lengthier version of that email address that I set up. So in this case, it's tester_whatever, and then so that's what I'm going to log in with. That's going to be my
So
user.
it's gonna actually pre-fill it, okay?
Yeah. So you can utilize that and your password that's pre-configured.
Yeah, because I was worried, like, I'm sure there is already somebody with that.
Oh, right. Yeah. So you just bind any email address to it, and it'll give you this unique email address that you can log in with.
And password you can modify for whatever you want.
Yep, exactly. Okay. So that's creating some test accounts. It's if you're working with any of the PayPal flow, just get familiarized with those two flows. They're dead simple for creating new users and creating API credentials, and that's 95% of everything that you're going to be utilizing with these payment flows. Okay, now some code. some practical implementations of everything that you're going to need to do to get the toolkit working. So first and foremost, you're going to have your script source includes. Everything that will include our client-side library and all of the digital goods flow that we have. First, we'll have our digital goods JavaScript library. That's going to be what controls initializing the Lightbox experience and making the requests through for actually making the payments and really just displaying that nice mobile experience. jQuery, that's just really for program flow. There's really nothing more to it. It's really will be bound into our existing toolkit. And then the pptransact.js under the clients folder. That's going to be our client-side program flow for making the back-end requests to our billing and verify.
Jonathan, is there a reason why the external DJ is not mobile?
No, so normally what I say for any external file includes is that when you're testing, it's okay to link to these absolute URLs on a different machine, but in production, it's always good to have localized copies of everything. It increases performance. Good point. All right, now you're going to initialize the library. First, you have to pick whether you want mobile support and pick the language that you want. This is all done through the initialization when you actually build out your flow. So there's a couple of ways that you can do it. The initialize functionality, the initialize method is going to accept two possible parameters. The first one is going to be the server-side language that you want to work with. So this is going to be Py for Python, PHP, CF for Cold Fusion, or Java. You can enter those in and it'll preload that library and tell the client side where to request or where to send all the requests to and where to actually do all the payment processing. Then second, the way that we set up the library in order to quickly support mobile was to have a flag in there whether you want a full page redirect or mobile flow. Let's say the Lightbox experience it doesn't work within the mobile environment. This is going to utilize a traditional express checkout flow that's kind of more of a full page redirect as opposed to the Lightbox flow in case you want it. This is defaulted to false, so if you need the experience, you can just turn it on to true. Obviously, future enhancements to the library, this is one of the things that we have filed as an issue on GitHub, is to replace this with automated code to detect the user environment and whether they might need that. Okay, then, and again, all of this stuff that I'm going through right now is all available in index.html in the file structure. So you can take a look through that, and that's going to show you all these mechanisms. The next thing you have to do is build in a billing handler. This is what's going to be utilized in order to fetch that token on PayPal side as well as committing the payment through. It's making the backend request actually do all this processing. So you're going to have in the user ID of current user, the item ID, and these can obviously be bound to your existing inventory and identity stores via those webhooks. Then the item quantity, again, inventory store or however many items the user's chosen. And then, like in any good old jQuery-ish function, we have success and fail cases. If the payment actually went through, if everything went through correctly. This is where you can bind yourself to additional actions after the user has billed and has gone through the billing experience. So let's say you want to go through the payment experience, the user has paid, and then you want to display some annoying blinking marquee or something like that. You can do that by binding into this nice little success case. Same thing with the fail.
So can you explain again the user ID and item ID?
So user ID is the current user that you want to build towards.
So how do I get that? I mean, like, that's what I'm confused.
Right. So that could be your current user. So the current user that you have in your identity data store. Then the item ID can come with whatever item ID you want to send through. This is your identifier for whatever the person is purchasing.
But wait, like, let's say, like, I create a simple button, right?
Mm-hmm. So
like, I want to charge randomly. So like, I created a donate site, right? So I want everybody to go to my site, donate me $5. So they click on donate and it goes to the open up this PayPal overlay, you know, and then then they try to log in, right? I mean, and once they log in, I'm gonna get their user ID.
This is just your basically your bound user identifier. So whatever you choose to put in here, then it will, when you go through the PayPal flow, it'll give you the unique identifier for the user. This is really just your identifier in the system. It can be whatever you push through right there to go to the digital goods flow. This is really just the toolkit side of things. This isn't the payment side of things.
Okay. So that's mine. That's not whoever tries to pay me money.
Exactly. So it's your identifier that you.
Oh, it's more like an app ID, right? Okay. Got
Yeah,
it.
so you can do app ID or user ID, basically anything you want. If you have a simple payment flow like that, though, I would just bind to the existing digital goods flow. The toolkit's not useful for that. It just has additional craft to it that's great for binding to inventory and identity systems, but it's not. It won't be great for just simple one-time purchases that have no identity information or nothing really of value beyond the purchase. So then the item quantity, these are really coming from your inventory store, or you can actually just, I can hard code these in. I can say item ID 123, item quantity 1. And you'll actually see how that works in when we cover the hooks. So in the inventory hooks and the identity hooks, you'll see exactly the default data that I enter in. And basically,
I see the index.html you just hard-coded some values, but I was just like if I put like instead of all 8s, if I put like 1s, it's still gonna work, right?
Yep. It's still going to work. It's really just binding to your inventory store if you choose to, or whatever value you want.
Right. So it's more like a local storage system.
Exactly. Yeah. And the way that billing's going to work, when we covered the the slight components in the architecture, but just driving down into the billing aspect, you're just going to make that billing request to digital goods. That's going to be the token and really pushing the user flow through. So the billing request is actually made to commit the payment, and then digital goods flow on PayPal side is going to say, yes, this payment succeeded or failed. Then in turn, we push the store information, basically what was purchased, the product information, to both local storage and, if you have the hook set up, to your purchase store, or your purchase storage. And then we have that success handler or the fail handler to handle user notification. So if you want to notify the user after that fact, load up the success.php or cancel.php, you can do that by binding to the success and fail cases in the jQuery AJAX request. Okay, much like the billing handler, you're going to have to set up a verification handler. The verification handler is really, again, just used to verify the purchases that the user has already made. So did you have a question? Oh. So much in the same way, you'll have your user identifier, your item identifier, same stuff as before, and then your success and fail cases. The way this is going to work is much in the same way. We're going to make a request to get the product storage. So this will be local storage, the inventory store, wherever the products are stored, we're going to fetch that data. The product storage will then send back a success or fail case. In the case of a fail case, it will just push you through a standard digital goods flow because it can't find any information that you've purchased. In the case of a success, the verification step is actually, you'll send back the verification data, and then you, as the client, can enable those items for the user. Now, whenever you go through and pull that data from local storage or pull from your existing inventory store, we will make those requests to PayPal to verify that data. This is the additional level of check to make sure that someone just hasn't entered that data or that something hasn't been modified on the client side. From an old CSI Miami, trust but verify, right? So that's exactly what we're doing. That's going to send back a success or fail message, and then you can utilize that to unlock the data. And finally, bind to your success or fail cases in order to produce a user notification. It's always good to bind to something. You can do whatever you want, whatever type of binding you want. It's completely open and up to you. Okay, so that is the architecture of how the entire flow works and the practical implementation for getting the HTML5 digital goods experience working within this toolkit. This is everything that you need to get started and start working with. Now, at that point, you can stop right there. You can statically hard code values in for the identity, for the item identifiers for the quantity, and just push through whatever the heck you want. It doesn't care whether you do that or have a scalable architecture. But if you want that scalable architecture that integrates with your existing systems, then you start really working with these product webhooks. So built into there, we have things to do things like identity and payments. So storing payment information after the user has purchased something for looking it up, and the same stuff we're storing in local storage, as well as the identity information, is a kind of a two-way street between PayPal and the client. So if we have no data about the identity of the user, no unique identifier that we can bind to our existing identity store, we have no purchasing information, PayPal itself, when you go through the purchasing experience, will pass that information back, and then we can have the data there. But if there is inventory and identity information available, we can just push those back through the PayPal side to verify the data. So it's a very much a two-way street. We can utilize it on the client side, or we can use it on the PayPal side to push back. In the verification handler, this would be your identity.php or .py or .whatever within the server folder. It's going to have a series of functions that are set up. These are all of our hooks that will tie to specific actions that are being made on this PayPal flow. First, we have a verified user, passing in a user identifier. Now, what you see up here, this user identifier 888 whatever, is a hard-coded value just to show you how you can bind to your identity store. Really, what you're going to want to do right here is you already know who your user is that's coming and viewing your site. So you're going to inject your identifier right here. That's going to pass through a true or false and return back true or false based on whether the user is existing. Then on a get user ID, this is another binder that binds directly to your identity store. Instead of sending back that true-false message, we'll send back the actual identifier for the user. Again, hard-coded results in here just to make it incredibly easy for someone to pick up this toolkit and just replace the default static values that are in there as placeholders. But once you have your user IDs, you can actually start working with payments. So this, instead of dealing directly with identity, is dealing with how PayPal or how payments is bound to the identifier. How, when the purchasing is going through, we can actually store those purchases. So one way of doing that is to record payment. When the PayPal digital goods flow completes, we're going to push to this key binder, which is a series of information like user ID, item ID, transaction ID, and all this stuff that you can use to store information about the purchase. Right here, right below that, this is where you can inject code to store into your existing database, your existing NoSQL store, whatever you have set up, to save that information. That's where you have that hook coming back in order to provide inventory or purchasing information for the user. Verification of the payment is just as it says. You pass in a user identifier, an item identifier, and it will check your inventory store to if that item is purchased by that user and still valid. So you're going to send back a true or false message depending on if that purchase actually went through. In the same way that we're using local storage to do the same thing. And then finally, we have a get payment. So the get payment information is going to provide back this type of information from your payment store. It's really just providing back that payment details that can be used for the verification process. This is a static object that you would replace with whatever user ID and item ID is coming through. So this is what you want to look up and provide back that payment information for. And that's how you bind to your payment and your identity architecture that might be already existing. We just need something in this format, but it's coming from your existing architecture, a very lightweight abstraction. Now, much like the identity and payment, we also have an inventory data store. And the inventory is going to provide us, well, just as you think, the inventory items that can be pushed through for the user. Like when you go through the billing object, there has an item ID and an item quantity. This is how you would bind to it. Unlike the existing identity and payment store, this is a one-way transaction. So you're only going to be calling this when you need to push through inventory information to PayPal. It's not going to be PayPal to store, and you will pass back information which you will store in your inventory store. It's really just a fetch. And to show this, we have getItem. This is the one and only function that's in existence within that inventory.php file. You have static object or a series of multi-dimensional array here, which stores information like mega shields or super missiles or whatever you're selling. And it'll have information about it, like the amounts that you want to pull through, or tax amounts that you want to pull through, quantity number, all of this information that is going to be used to utilize the payment flow. So this, in a nutshell, so all of these components, the architecture, the implementation, these webhooks, are how you can bind yourself easily to a payment flow, without having to deal with all of this yourself. Really, all you're doing is calling two functions. You're calling two functions to bill and verify, and that's it. So the toolkit is trying to abstract out all the complexities of payments very easily using this lightweight HTML5 component. And if you're integrating it, it's very easy to figure out whether it's a right fit for you. First, do you have that HTML5 support in place? If you don't, the toolkit might also be valid for you if you want to bind to your inventory stores or your identity stores. You can easily remove this component from the toolkit. Then, do you need to accept some sort of payments? And are those payments digital in nature? Now, if you have a yes answer to this, then this toolkit is perfectly aligned with what you're building out. I want a simple, easy way of purchasing digital goods for your application. That's all it is. So just to recap a couple of the links that we went through today. The HTML5 toolkit is available on our GitHub account on the PayPal/HTML5-DG. The sandbox where you would create test users and create your API credentials are available at developer.paypal.com. And if you want to download the JS Wars demo code, it's all available under their site there. Alright, so thank you very much, everyone. I'll open for questions, but if you want to download anything within the SlideShare account, these slides are all available within this bit.ly URL. bit.ly/svcc_in-app payments.
So quick question.
Yep.
I play with another similar API that they have for iPhone native, Android native. What is this stuff? I mean, it's also like you have this pop-up. I understand here you have basically the ID and you can kind of track the whole user interaction. But what are the other payment APIs that you guys also exposing in PayPal?
So we have, there's a lot within PayPal.
Right.
So there's a native iPhone client, native Android client. These are all really binding to native experiences. Then there's, tons of different payment options like adaptive payments. Underneath there, change payments, parallel. There's a lot. This is really just the lighter weight touch Lightbox experience. It was really built for real-time gaming, for quick in-app purchases without breaking the experience. That's what it was built for, and on its own, it's great and easy to use. This is just a way of enhancing it a little bit with some different components. Great. Feel free.
I work with John at PayPal. The big difference is in Android and iOS, you are supposed to use their native payment options, like Apple in-app and Google in-app in case of Android. So if you want to build a native game or a native application, you want to collect payments for anything digital that's consumed within the device, you must go with them. So you can't really use PayPal for that. So the PayPal does have native solutions called native mobile payment libraries for Android, BlackBerry, and iOS. But the problem is you can only use them for physical goods services, not B2B, but not for digital stuff.
Okay, so it's only for physical.
Yeah, the primary reason why we did this is in the new HTML5 world, more and more people are going into the web-based games. So we needed a better way for them to do it. There's no reason why you can use this. You can always directly use PayPal APIs too, but without this, you have to pretty much do the same thing. You need to build all the back and forth to do your inventory checks, your user checks, or the payment that you may or not.
Yeah. And one of the things that you can take a look at on the Digital Goods Flow, this is the Digital Goods homepage. And one really good showcase for what it is if you go to how it works, it's a small little video that shows some practical use cases and how it's very applicable to whatever you're doing. Yes.
How about PhoneGap applications? How would you tie in with those?
So there's not direct integration within there, but within PhoneGap applications, since you have this HTML5 base, it should process down to native.
Will it be considered as a native application?
Yeah, it would be considered a
You
native.
cannot really use it for digital goods, but if you're looking for something like physical goods services, PhoneGap, we actually do have plugins for PhoneGap to work with PayPal. But not, you can only use them for physical goods.
Yeah.
For
For physical goods and services.
So this is
So
primarily for browser-based.
it's really primarily for browser-based.
Yeah, you have to be very careful. Like the iPhone store, they're very, very strict about it, and they'll catch your app right away before it goes to the store. On the Android store, typically what's going to happen is your app's going to go in there, and then a month later, they're going to just pull it. So that's happened on many different occasions when you're not using any of their internal stores. So it's better just to have this web environment set up.
So when you say that you cannot do it, you're just saying that they have rules against it. It's not that you couldn't write the technology and build it and it would work. It's that they're probably going to
It's
take it out of
Exactly.
It's basically the developer restrictions.
So technically everything can be done.
So like if you want to sell articles, is it considered to be digital goods? So it's
Unfortunately, yes.
okay.
USA Today, they all struggle.
Okay.
Couple of things. One is two flows. How do you handle subscription flow here?
So the subscription flow,
Monthly subscription or anything else?
so the subscription flow would be under a different type of model, but this express checkout experience, it's doing
Always
one-time
one-time
payment. Yeah, one-time payment.
So
Now,
you
the
don't
subs-
support subscription.
So the subscription model, so in this type of experience, what you would have mainly is a single purchase that would last for a certain number of time. So what you could do within the toolkit is you purchase for a certain amount of time, and then there's an expiration. Yeah, there's definitely an expiration or something like that, but it's a one time.
You can, the toolkit is built for one-time payments, but definitely you can expand the PP transact.php or
Yeah, pptransact.php.
There is a different API that you call to create a business payment.
Exactly.
And PayPal will take
Yeah, because many times rather than paying every time, I can say monthly I'll pay maximum $30
Exactly.
and keep deducting from there.
So one of the things that we definitely wanted to do within this toolkit was expand just beyond the digital goods express checkout experience. There's a whole host of great payment options that we would love to integrate, that we will be integrating and working with to extend this, and subscription-based models is something that we actually have an issue open for. So if you take a look at the issues on the GitHub repository, it's probably number 4, number 5, somewhere in there. You'll see something that supports subscription models.
My second question is, how do you support here models like, hey, doing a free subscription initially for 30 days and then charging? How do you support those?
That's again another type of payment model that.
What I want to do is say, even in these games, right? Hey, for the first 30 times when they're asking for it, I want to offer it freely.
Yeah.
But after 30th time, right, maybe I just want to charge, right? It's like giving a free lollipop type.
Yeah.
So how do you build those type?
So that's basically what you would want to, and that's again another type of payment model is not directly built into this. So what we could do is utilize the so you can pre-verification within PayPal. You can pre-verify a person's credentials and lock those up. So you can lock those directly in for a future payment at a specific date. And that's how you can technically do it with a 30-day subscription model. It's not built directly into this. Again, it's the same thing as the subscription-based model. It would have to be extended. So that's how you could traditionally do it.
But you don't have it like.
Not built directly in. No.
It should be pretty straightforward. If I correctly understand, you're saying you want to track the clicks of the user.
That is one way, or another thing is track it. Give it
It's
free for the first
free for
30
30
days.
days.
The time base is pretty straightforward with PayPal API. In every subscription, you can say what's the initial trial period,
Yeah.
and then PayPal will hold on until the trial period and then start charging the user. But if you want to do like tracking how many times the user is trying to do something,
Exactly, right.
then if you can extend the toolkit and wherever you have the user ID and inventory, you can save that in your database to see that how many times you are trying to do this,
Exactly.
and then kickstart the flow for the nth time whenever it triggers.
And do you also support multi-currency?
Yeah, it's support within there to do multi-codes.
What is the minimum amount you can charge?
And the minimum amount,
You can charge.
it could be anything. But the PayPal fee itself is not PayPal fee structure.
So it's charged like 1 cent or less than 1 cent.
Now,
It probably won't be economical to you. The PayPal
Because-
typical transaction model is 2.9% and 30 cents for anything over $10. Less than $10 is 5% and 5 cents. So if you do anything less than $1, you're gonna probably be paying 10 cents. So
yeah, with the micropayment option, here's the pricing model right up here. I figured that this question would come up. I think when I figured it out, the $15 to $16 range is when micropayments cheaper on $15, micropayments not cheaper on $16. So that would go to an existing pricing model. So that's where you would just go through this flow.
So that even for $0 offerings, we have to pay PayPal, right?
there's no such thing as a $0 payment. But if you wanna make us rich, yeah.
Yeah. You could just very easily adopt those as a
There
buy it
is
now
some-
button and bypass this.
People typically do, they actually do $0 authorizations even though they never charge them.
Yeah,
Only to confirm that the information that a user gave is actually valid or not.
exactly, right.
But in charging, no one really charges. No one captures the payment.
Yeah.
Okay.
Any other questions? Great. Well, my contact information, if you want to contact me in the future, if you have any questions throughout this flow, anything about the toolkit, feel free to reach out, jlamon at paypal.com or ebay.com or x.com, pick one. You can go with any of them on Twitter, and you can find me on GitHub as well, see a lot of the code check-ins from there. And again, this entire presentation is available on my SlideShare account, so if you want that. Thank you very much, everyone.